It's one thing to listen to doom and gloom about food and fertilizer shortages, skyrocketing prices, the cost of living, or your job being outsourced overseas or eliminated due to automation. It's quite another thing to hear practical, immediately actionable advice from experts who can help you reduce the fear, anxiety, and burden of these problems. Tune in now to the Surviving Hard Times podcast from the Finding Genius Foundation with Richard Jacobs. Before we begin, a note from our sponsor. I'm Richard Jacobs, Executive Director of the nonprofit Finding Genius Foundation and host of the Finding Genius podcast. In late 2016, I was rear-ended at 65 miles an hour by a truck on the highway, which sent me off-road into a ditch. The impact of the collision gave me a concussion and other injuries. At the hospital, a CT scan showed that I had thyroid nodules, which turned out to be cancer. It was then, when I had a biopsy of my neck, that I realized even if I was a millionaire, I wouldn't want a second or a third biopsy due to the pain and the invasiveness of it. And appointments at that time for thyroid experts were 3 to 6 months out. And I was worried about dying now, even if that was irrational. So because of this, I've decided to raise money to conduct a literature review on steroids, on the causes of anxiety and depression, a condition that affects well over 50 million people in the United States and hundreds of millions worldwide. Our goal is to create a codex, a guide that reveals all possible treatments for anxiety and depression for people that live with the condition, or for loved ones that have it, as my wife and my son do. To find out more about our fundraiser, visit findinggeniusfoundation.org and click on Current Initiatives. And now, to our guest. Hello, this is Richard Jacobs with the Surviving Hard Times podcast, sponsored by the Finding Genius Foundation. My guest is Rich Marini. He's a professor of horticulture at PSU. So we're going to talk about his research on fruit tree physiology, etc. So, Rich, thank you for coming.
Sure, you're welcome.
Well, tell me, what's a bit about your background? How did you get interested in fruit trees and horticulture and stuff like that?
Well, I think it goes back to my childhood. My grandparents had a vegetable farm, and my dad was a county agent. I was in a 4-H gardening project, so I guess I just kind of grew up with horticulture. So I guess that's where my interest came from.
Oh, that's great. So what's your current research about today? What are you focusing on?
Actually, I just retired about a month ago. The last couple of years, I've been working on a bitter pit, which is a disorder in apples. Especially Honeycrisp is very susceptible. And,
I've had Honeycrisp. You said it's called bitter pit. What is it?
Yeah, so what it is, it's a tough one to work on because when you pick it, the apple looks fine. You put it in cold storage for a few months, and then when you take it out, it still looks good. Leave it at room temperature for a few days, and you get these sunken black areas, mostly at the blossom end of the fruit, so it's the opposite from the stem end. And it goes, maybe a 1/16 of an inch deep. It can be removed and eaten, but sometimes it develops on the grocery store shelf, and that's not good. And it's caused by there's not enough calcium in the fruit. Some varieties are more susceptible than others, and Honeycrisp is real susceptible. So.
Well, is it poisonous, or does it just taste gross, or what's the problem with it?
No, it's not poisonous. I don't know how it tastes because I've never tried it, but it doesn't look good. And if it develops in storage, the fruit can rot sometimes. So it's not a good. So it's a nutritional disorder in the fruit. So.
Oh, okay. Did you ever figure out how it happens, or you said it's from not enough calcium, but is it not enough calcium at every stage of the trees growing, or is it at certain stages?
No, there's been a lot of work done on it in the last few years, and I didn't find this, but recently they found that the primary problem, that's a variety like Honeycrisp, there's a vascular system in the tree, which is similar to blood vessels in animals, I guess. It's like the pipelines that bring water and elements and sugars from the roots to the top of the tree, and they go all the way into the apple itself. And for some reason, Honeycrisp, these pipelines plug up pretty early in the season, so calcium doesn't move into the fruit. And so that seems to be the problem. So that's just been found in the last 4 or 5 years.
But visually, you can't tell? Is there a way to tell early what you can do to prevent this, or no?
Yeah, well, the way we prevent it, I think that's worked best so far at least, is we spray calcium on the tree. So we usually spray calcium chloride on the tree about 8 times every season. So that way the calcium is absorbed directly into the fruit. And it helps. It won't eliminate it, but it helps.
Right, I got you. Okay. Any other interesting puzzles you've discovered around fruit in your career?
For the last couple of years, the other area I've been working on is trying to predict size of apples at harvest time by measuring them early in the season. So that's kind of a statistical problem. So those are the last 2 things I was working on. I was also doing some work with raspberries, growing them in high tunnels. High tunnels are similar to
like a greenhouse, kind of like a hoop house in a way.
Yeah, it's more like a hoop house. So it's like an unheated greenhouse. And raspberries really grow well under those conditions, at least in the Northeast. And we were testing different kinds of plastic. You can cover these houses with different kinds of plastic. In the summer, it gets pretty hot on a sunny day, so we were trying to cover them with plastics that blocked wavelengths to see if we could keep it a little cooler. And one of the things we found was that plastic that blocks ultraviolet radiation, it helps control Japanese beetles. So Japanese beetles really like to feed on raspberries. And we found when we covered a house with UV blocking plastic, we didn't have any Japanese beetles. So that was kind of neat.
Good question. It seems like fruit trees take, 3 to 5 years to produce fruit. Has anyone figured out why or how to accelerate that, or how does the tree know when to produce fruit in it?
Actually, we have accelerated it. So fruit trees are, and a lot of other kinds of trees, are propagated on rootstocks. So if you plant an apple seed, it won't give you a tree that's the same variety as the variety that the seed came from. Okay, so it's going to be something different, usually not nearly as good. So the only way we can maintain a variety is vegetatively propagating it. So some plants can be vegetatively propagated by making cuttings. Unfortunately, apples don't root very easily. So the way we do it is we graft onto another apple tree. So that's called a rootstock. And so we have some dwarfing roots. Almost every orchard now is planted on dwarfed rootstocks. And these dwarfing rootstocks make the tree fruit a little bit earlier. So if you have a tree that really is growing very well in the nursery, usually we can get a little bit of fruit the second year, by the third year for sure. So we've shortened it up a lot, mostly with the use of a rootstock, and also the nurseries are growing much better quality trees than they did 20 years ago. And it's probably based on the hormones in the tree, most likely. I don't think they've identified some of the genes that are involved. I don't think they know exactly how the genes work.
But is there anything you could do with light and dark cycles, or, heat and cold? Is there any way to accelerate? I don't know what the term is called, when the tree grows, I guess it's in its vegetative stage until it produces fruit, but is there any way to accelerate this?
I haven't seen any work on that, because you'd have to do that all the entire season probably. And I don't think so. So sometimes trees that are growing very vigorously will have delayed fruiting. So if you fertilize them too much or you prune them too much, that'll delay fruiting. A lot of times we try to avoid that, but I don't know anybody that's tried to really manipulate the environment to get them to fruit sooner. That would be hard to do in the field.
I don't know. Does anyone have a desire to do it, or if there's certain weather patterns with certain fruit trees, have people noticed that? I'm sure there's plenty of instances where they don't go to fruit. So there's probably a lot of stuff that prevents them, but is there anything that encourages them or accelerates them?
Well, with the fruit trees we grow, I don't think so. I've been involved in multi-state research projects where we have the same variety on the same rootstocks that we obtain from the same nurseries, all the way from Georgia and Alabama up to Nova Scotia and British Columbia, and they all fruit about the same time. They take about the same length of time to fruit. So the rootstock seems to be more important than anything else. So,
what does it mean? The condition of the roots, or the spread of the roots, or what do you mean?
No, I don't know what it is. It's something, the genetics of the rootstock. So there's a communication between the top of the tree and the roots. So a rootstock, it's a grafted tree, and genetic material can get through that graft. So they found RNA from the rootstock in the top of the tree. So So the rootstock can really have a huge impact on the top of the tree. Part of it is it'll influence the ultimate size of the tree, when it starts to produce fruit, disease resistance, even fruit size. So we can really manipulate a tree quite a bit just by changing the rootstock, and that's how we've been doing it more recently. We grow more dwarfing.
When you say when you say manipulating the rootstock, what does that mean? What kind of experiments have you done? What people have done?
Well, we just try different rootstocks. We have right now commercially there are probably more than 30 rootstocks available from commercial nurseries now, and they all have different characteristics. So depending on what a grower wants, they can use different rootstocks. But most of the new rootstocks.
What does that mean? You're grafting on the roots of another fruit tree of the same type, or what does it mean? The rootstock change.
The rootstock is actually another. It's another variety of apple, basically, but it's been selected because it roots easily. So we can root new trees from the rootstock. So we're producing the rootstock with vegetative reproduction by making cuttings. Sort of. It's more complicated than that, but basically it's a cutting, and then we graft the variety we want onto that. So that's the way it's been done for a couple thousand years. So every
it's been done this way for thousands of years, literally. When was it discovered?
Yeah, literally. Yeah, the dwarfing rootstocks. One of the dwarfing rootstocks we use now, they think Alexander the Great brought it back to Europe from his conquest in Asia. So
that's amazing.
That rootstock's pretty old. Yeah, there's a lot of instances in the ancient literature that they talk about grafting. So grafting is goes back to ancient times.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
Oh, wow. Okay.
Yeah.
So rootstocks, again, it allows the plant to root very easily, but does that mean it changes over the whole plant to become whatever that rootstock is? Or what happens if you get like a Frankenstein, one kind of apple with a rootstock from another kind of apple? What happens to it?
Yeah, if you don't graft the rootstock, just let the rootstock grow into a tree, it'll produce fruit, but most of them, they're more like crab apples. They don't taste good. They're small, usually pretty tart. But by grafting onto it, it doesn't change. So if you put a Golden Delicious onto 5 different rootstocks, they're all going to produce Golden Delicious. So it doesn't really affect fruit itself. It just kind of changes the growth habit of the tree. It might make it, and it may influence the disease resistance, but you're still going to have the same variety on top. It doesn't change that. I don't know. This is
okay.
In my class when I used to teach tree fruit. I spent a whole couple of lectures on rootstocks. So you're into kind of a complicated subject here. But,
well, no problem. Maybe we could just cover a few points of it. So how do you match a rootstock with a tree, and how do people know when it's going to work and when it's not, and what kind of attributes can you tweak doing it?
Well, it's mostly trial and error. So right now there's one rootstock breeding program in the United States, and that's a joint effort between Cornell University and the USDA. And so the rootstock breeder is testing a lot of these trees for various characteristics. And when he gets one that he thinks is pretty good, then they make it available to researchers. We can test them to see how they compare to the rootstocks we already have. We're looking to improve it if we can.
Well, what does it look like, a rootstock? Is it just like a small piece of root, or is it like a whole big tangle of roots? And, how do you graft it onto the existing tree?
The rootstock is really very small. One shoot, it's maybe a foot long, and it's got a little bit of roots on the bottom, but not much. And so they're usually about pencil thickness, and we just take a piece of a variety, a shoot from a variety like Gala, Golden Delicious, Fuji, whatever, and we can graft it on, and then we grow it in the nursery for 1 year. By then, the tree in the commercial nurseries, they can grow them better than I can. The tree will be 6 feet tall, and it'll have 4 or 5 branches on it at the end of 1 year. And then they'll dig those up and sell it to whoever wants to buy the tree.
What about the microbiome of the roots? Do they wash the rootstock off, and then once you transfer it, just a new microbiome is created in that new soil, that new environment? Or does anyone try to preserve some of the dirt along with the roots and plant both?
Well, generally, the nurseries fumigate the soil before they plant. So they're trying to kill nematodes are a problem because there are some species of nematodes that serve as a vector for viruses. And there may be some pathogenic fungi or even bacteria in the soil. So usually they fumigate before they plant. So I don't know what's on the roots, but when they dig them, they just shake the dirt off, the soil off. So they don't wash them off. They usually just shake it. And then they sell a bare-rooted tree. But depending on the nursery, there's going to be different microorganisms on those roots.
All right, sure. Okay, so how do they graft it? Do they just tie it to an existing root, or do they make holes and kind of like make male female holes and smush the roots together so the juices of them are mixing, or how do they graft them?
Well, there's a lot of different kinds of grafts that can be done, and even some of them are budded. So all you need to do is just you can the simplest one is called a cleft graft. So you can make sort of a V-shaped cut off the rootstock, and you kind of split it vertically, and then the variety you're going to put on top is referred to as a scion, and we can make that sort of a pointed shape, and then you stick that pointed shape into the vertical slit. So if you look at a cross section of the shoot or a tree, there's a green ring on the inside of the bark, and that's called the cambium, and that's where new cells are formed. And so as long as the cambium of the scion lines up with the cambium of the rootstock, they grow together, and it makes a very strong union. And so that's all it is. And there's different ways to do it. There's a lot of different kinds of grafts. The other way to do it is just take a bud from your scion variety